All right, what's up? I am gonna try to get through this test review quickly. Let's see, this is AASL 2. All right, we're taking the integral of -1/2. That's a coefficient. I'm just gonna leave that alone. The integral of cosecant squared. I should know that the derivative of cotangent is cosecant squared, and it's negative. So my integral of cosecant squared should be negative cotangent. And these two negatives are gonna make a positive. So I'm looking at 1/2 cotangent. Oof, I'm missing an x here. So plus c. You get to see live how we're gonna do this. Hopefully I don't have a typo on every single question. HL, SL, we need an X. It's a minor one. Okay, we're back. Number 2, coefficient. I see that I have x squared, cosine. I'm thinking that is two things multiplied together. That is a big problem in SL. We pretty much, why is this so bad and dark? Whoa, okay, better I guess. We don't have to deal with this. I'm going u equals x cubed, du dx is equal to 3x squared. I'm seeing nice, that's gonna match up. I'm gonna do my replacements. 6 integral x squared cosine of u du. These are gonna swap. 3x squared, my x squareds will cancel out. My 3 and my 6 will make a 2. The answer is gonna be 2 cosine u plus c, but I can't leave it as a u. 2 cosine of x cubed plus c. For this next one, I'm noticing I have two things that are divided. Maybe I can divide them. I noticed that I think I can factor the bottom with difference of squares, but even if I do, it doesn't cancel out with the top, and so I'm probably thinking u substitution again. U equals x squared minus 4, du equals 2x. That's dx. Those are going to swap. The integral of 2x. This is going to be u du over 2x. Oh, it's a perfect match. The integral of 1 over u du. That's just like the integral of u to the -1 du. But I know that the integral of 1 over something is natural log. So I'm thinking this is going to be the natural log of x squared minus 4 plus c. Maybe I'll mix these up. These are messy. This next question, we got a hint. If calculus won't seem to work, try algebra, because if I do the same thing and I get my u is 2x and then I try, it's not going to cancel out. So the hint says try algebra. I think I can factor the bottom. X minus 2, x plus 2. But that still doesn't cross out perfectly on the top. I think I'm noticing that I need to do GCF. And now it will cross out. And so I can write this as 2 integral 1 over x plus 2 dx. And I could do a u substitution, but 2 natural log x plus 2 plus c. Get out of the way, Gord. Fast, fast, fast. The directions do say I need to do this work by hand if I can, so let's get into it. The integral, that should be an easy piece. This is a little bit messier, so maybe I'll think of this as two separate integrals from 1 to 2 of 4 to the x cubed dx minus 2 pi integral sine of pi x dx. Took the constants out front. Now I want to look at the integral of this. Add 1 to make 4, divide by 4. That's perfect. That's going to be x power 4 from 2 to 1. This, I know I have this interior function. If I do the u substitution, it'll tell me to divide by pi. And so if I divide by pi, it's going to get rid of that there. So I'm thinking that this pi is going to go away. -2 times the integral of sine is negative cosine. And so that's going to make this negative into a positive cosine pi x from 2 to 1. Oh, I need to label that. A little bit of a little bit funky just because this pi went away, because I kept track of the chain rule in my head. This pi, u equals pi x, du equals pi over dx, they switch. Okay. Now, maybe this just says 2 times cosine pi x, so I don't think I even need the parentheses there. It's just 2 that. So let's plug this in. That would be 2 power 4 minus 1 power 4 plus 2 cosine 2 pi minus 2 cosine 1 pi. That is 16. That is 1. Cosine of 2 pi. Cosine looks like this. 2 pi is 1. 2 times 1 is 2. And then 1 pi is -1. So that's going to be positive 2. So that's going to be 20 minus 1, 19 as our final answer. If you want to double check, you can use your calculator to double check. The bottom here. Consider the function of the quadratic y equals x squared that has been translated 1 unit to the right and 1 unit down. Sketch the function on the above graph. Make sure to accurately plot the points at each integer where. Okay. So that's -5 to 5. It just means to plot the points accurately. I know I need to go to the right one and down one, which means that my vertex will be here. And then over 1, up 1, over 2, up 4. If you're not sure where those numbers are coming from, maybe we look at b first. It says write the equation for this function in vertex form. So b, y equals x squared, but we need to be shifted to the right one, -1, and down 1, -1 again. So you could just plug in these points. 1 is 1 minus 1, which makes 0 squared is 0, minus 1 is -1. 2 minus 1 is 1, squared is 1, minus 1 is 0. So you could just plug them in like that. Let me go ahead and get this graphed up. It's a little bit messy, but I got them all. Did I sketch them and plot the points? Yes. At this point, it's going to be too high. The y values are too big, so that's okay. Write the equation C. This equation has 2 x-intercepts. It goes below the x-axis for a short period, but then remains above the x-axis after the second intercept. On what interval from 0 to k is the area above the x-axis equal to the area below it? And D says color the graph. Okay, so what they're saying here is that below the x-intercept, we get all this area, which is like negative area, and then after that, we start getting some positive area. And I'm not sure if it keeps going, what is this, 3? I'm not sure if it keeps going to 3, or if it keeps going to 4, or if it's 3.5, or if it's 3.2, or if it's maybe pi or something, I'm not sure. On what interval from 0 to k is the area above the x-axis equal to the area below it? Well, that means that my area under the curve would be 0 if the below and above were equal to each other. So what I'm going to do here is set up a little integral from 0 to k of x minus 1 squared minus 1 dx, and that's equal to 0 because my area above and below are equal to each other. I need to take the integral of this. I would probably just FOIL this out. The integral from 0 to k, That's going to be x squared minus 2x plus 1 minus 1 dx equals 0. Obviously, plus 1 minus 1 going to go away. The integral of these things should be pretty easy. 1/3 x cubed minus x squared from 0 to k. And remember, all of this should be equal to 0. I'm just not sure what k is to make it 0. I'm going to go ahead and plug these things in. That would be 1/3 k cubed minus k squared minus 1/3 0 cubed minus 0 squared. All of that is going to be 0. Go ahead and rewrite this over here. We've got 1/3 k cubed minus k squared is equal to 0. I think we can just factor this. Bring out do a GCF. K squared 1/3 k minus 1 equals 0. Set both of these separately equal to 0. K squared equals 0. That's k equals 0. That makes sense. The area above and below would both be equal at 0 if we went from 0 to 0, because it wouldn't go anywhere. Then we have 1/3 k minus 1 equals 0, 1/3 k equals 1, times 3 on both sides, k equals 3. This is kind of a dumb answer. So really, so interesting. I'm going to go ahead and finish D by coloring. The amount below right here is exactly the same as the amount above right there. Neat. Cool. Let's keep going. The following diagram shows the graphs of position, velocity, acceleration. Okay, complete the table by noting which graph A, B, or C corresponds. Okay, this should be easy. I see a linear, a quadratic, and a cubic. I know that when I take derivatives, they get degraded. And so what I'm thinking is the most complicated graph should be position, and then it will get degraded into the medium velocity, and then it will get degraded into the simplest acceleration. So position should be the most complicated, should be the cubic graph, should be graph A, and the acceleration should be the simplest graph, the linear graph, should be graph B. State the value of t when velocity is at its highest. Velocity is the one we haven't talked about yet. When is velocity at its peak? At the t value of 3. That was such an easy question. We love that. Calculator permitted. If the velocity of an object traveling in a vacuum can be modeled by the equation v of t equals 1/2 cosine pi x in radians, find the displacement of the object after. Calculator permitted. Displacement is talking about the integral from, it says after 1 second, so from 0 to 1. Cool, let's just do that. Second window, nope. Alpha window, no, stop. Alpha window, integral from 0 to 1 of 0.5 cosine pi x dx in radians. This is 0. You know what? I probably would recommend that we also write down this so that in case we get it wrong, we could get some bonus points. Or not bonus points, but partial credit. I know this is correct, but just a good habit to make sure we're getting as many partial credits as we can. After 1.5, I'm just gonna go back, scroll up and press enter. I'm gonna scroll to the beginning and do a 1.5. It's kind of weird. Okay. Displacement for B is negative 0.159 of the integral from 0 to 1.5 cosine pi x dx. And C, this is going really well so far. Just from 0 to 2. Now this says 1.6 e to the negative 14. E is scientific notation, and that basically means 0. Because if we have negative 14, that means 0.0000000000000000016. That is basically 0. That's just a calculator problem. So what is going on here? I'm thinking, it says use your knowledge of trigonometry to find an interval where displacement is greatest. I'm thinking that these are trigonometry, and so they're gonna oscillate back and forth. They're gonna go up and then down and then up and then down and then up and then down. And so my displacement would go positive and then negative and then positive and then negative. It wouldn't actually go anywhere. It would just stick around. I'm gonna go ahead and look at this graph. Let's see here. 0.5 cosine of pi x. Okay, and I'm gonna set up my window. It's 0.5 cosine, so I'm gonna say that my y minimum is 1, negative 1. Maximum is 1. My x window, I guess I'll do from 0, and then it's radians, right? So I should be able to do, but we have this pi here that's converting all of these, so I guess I'll do like, I guess 10 is fine. Let's just see what it looks like. Okay, so that's kind of what we expected. It just is oscillating back and forth. If we're gonna look for a window where displacement is greatest, then we need to look for a window where it has the most positive pieces. It doesn't have any of that negative issue. And so I'm thinking that if we try to go, this is 1, 2, 3. If we try to go from about 1.5 to 2.5, that would be only positive area and no negative area. And so I think in order to avoid these negative areas, we need to make an interval something like 1.5 to 2.5. If we calculate that interval, oh shoot, don't do that. 1.5 to 2.5 of 0.5 cosine pi x dx. It's going to get me a positive number, and I don't think I can get a bigger number than that, because that is, look, I can even do this. Second, calculate the integral from 1.5 to 2.5. You see, it'll color it in like that, and it gives me the same number. And I don't, if I go any before, it's going to be negative, and if I go any after, it's going to be negative. I think there's many answers for this. 1.5 to 2.5, 3.5 to 4.5. Those would all be valid answers. Okay. Weird question. We got one question, yeah, one page left. A couple of these intervals, and then we'll be done. Um, I could maybe factor the bottom there. Would that be worth it? Oh yeah, that's nice. Might as well just go away. So really I just want the integral of 1 over x minus 3 dx, which is easy. ln of x minus 3 plus c. If I didn't do that, I would have to consider u substitution. Yeah, I would have to consider u substitution. Okay. Number 10. I can't do the same GCF thing. I have this squared here. I'm thinking I want to do u substitution. U equals 3x minus 7 du dx equals 3. So don't forget to divide by 3. The integral of 3, I'll just put that out front, u squared du over 3. The 3's will cancel out. The integral of u to the negative 2 du, add 1, which makes negative 1, and then divide by that. Negative u to the negative 1 power. This is an easy question. I guess plus c, and so negative 1 over 3x minus 7 plus c. Not too bad. Last question here. I definitely am going to need u substitution. Oh, the lights are turning off. I've been here all night. Oh my god. Don't look at the time. That's dx. So I need to make sure I divide by 3x squared. The integral of x squared e to the u du divided by 3x squared. The x squareds go away. Don't forget that 3. 1/3 the integral of e to the u du. E to the u is very easy. It's just e to the u plus c, plug it in, 1/3 e to the x cubed minus 2 plus c. All right, that was maybe too fast, but that's what you get. I'm here way too late. I'll leave the key. Have a good weekend.